So here's a vector problem where we have to integrate or differentiate. So let's have a look. We are given at time t seconds, p is moving in a plane with velocity of v meters per second, where v is defined as this equation. We're also given an example where when t equals 0, we are told that the displacement of the particle is j meters. Right. So let's have a look. What do we do? So for part A, find the expression for the displacement. So we know that displacement, velocity, acceleration. The change in displacement, ds over dt, gives me velocity. The change in velocity is dv over dt, gives me acceleration. If I was going the other direction, that means I must have to integrate. So I integrate a with respect to t, and equally I integrate v with respect to t. So I've got v and I want s. So I'm going to have to integrate. So I take the fact that I want the integral of v dt, and that's going to give me r, my displacement, plus c, because this is basically an undefined integral, so I don't have limits. Okay, right, so let's take our argument. So I've got 4t plus 1 dt, that's my I, and then I'm going to take away the integral of 2kj dt. Okay, so when I integrate, like 4t becomes 4t squared divided by 2, so that's 2t squared. My 1 becomes t, and then I'm going to subtract my 2k is going to become t, 2kt, and of course I always get an undefined integral, I get plus c. So now I've got, that's what I've got here. Right, so now I've got my integral. But I've got a c, I've got an unknown. Basically, when we differentiate, constants become 0, they disappear. So therefore, when I integrate to the inverse, I've kind of lost the information. I have to find out what c is. So now at this point, I have to use my example. So my example is that when t equals 0, the displacement, which I've just worked out, is equal to 0i plus j. So this means that my integral 2t squared plus t minus 2kt plus c is equal to 0i plus j. Remember, sorry, let's put those. So that's my I, and that is my j. Okay, so this tells me basically that now when t equals 0, I'm going to substitute each of my t's for 0. So that means that this is going to be 0 plus 0 minus 0 plus c equals 0i plus j. So we have found the value of c because that's the only non-zero term. Okay, great. So now I'm going to put them together, and I can write this as 2t squared, and that's my displacement, 2t squared plus t, and that is my I component, plus, remember now the c has no I component, but I've got 1j, so I've got 1 minus the 2k t that we found with our integral here, and that's my j. And I've got meters because remember this is a displacement argument, so that is my a taken care of. Right, now it tells me there's a second particle q also moving in a plane. Its velocity is given as 5i minus 3tj, where t is greater than 0. And again, it gives me another example. It tells me when t is equal to 0, the displacement of q is 2j meters. So now we're going to think in terms of q. So I've got my velocity and I want displacement. So again, I'm going to integrate velocity with respect to t, and I'm going to get displacement plus c. Okay, so the integral of my 5 minus 3t dt is equal to 5t minus 3 over 2t squared plus c. Right, now I use my example because I'm going to plug my t equals 0 into here. So that's going to give me 5 times 0, which is 0, minus 3 over 2 times t squared, which is 0, plus c. Okay, and then that is equal to 2j. So now I have my c value. Okay, so my displacement vector is 5t times I plus my 2j from c, 2 minus my 3 over 2 t squared j. So that's my displacement vector for q. Now, given that the particles collide, find the value of k. Okay, so what I know is if they collide, then my two vectors have the same position vectors in the same place at the same time. So that means that 5t I plus 2 minus 3 over 2t squared j is equal to 2t squared plus t I plus 1 minus 2k t j. So now I can look at these, and the k that I want is in the j component. So what I want to do, I want to equate my two j components. Now that means that 2 minus 3 over 2t squared is equal to 1 minus 2kt. And what I do is I rearrange this into a quadratic, which gives me 3 over 2 t squared minus 2kt minus 1 equals 0. And I need to find my t value. So let's look at the I. I know that my 2t squared plus t is equal to 5t for I. So that tells me that t is equal to 2. So I'll feed that back into my j component. And that now means that I've got 6 minus 4k minus 1 equals 0. So k equals 5 over 4. That's that done. Last part, what's the position vector of the point of collision? Well, I know what k is now. I know what t is. If I feed these back into one of my equations, so if we put it back into, let's call this equation 1 for q, okay, and we'll feed it for that. So I'll substitute in. So I've got 5 times 2i plus 2 minus 3 over 2 times t squared j. It gives me 5 times 2, that's easy, that's 10i. Now I've got 2 minus 3 over 2, so I've got 2 squared is 4, divided by 2, that's 2, 2 times 3 is 6, 2 minus 6 minus 4j. That is the position vector at the point of collision. Okay, I hope that's clear. Remember, when you're integrating, we need to find a coefficient, a constant of integration. And a constant integration comes by using the examples we're given.